Hello everyone, myself Dr. Feroza D. Mirajkar, and today we will see a 8051 program for BCD down counter. Here this program functions as a BCD, that is binary coded decimal down counter, and it continuously decrements the value in the accumulator and updates the memory location and ensures the valid BCD representation using the decimal adjust after instruction. This is the overall logic of the program. First, we have to initialize the counter. So the counter is set to start at 99. Then you have to decrement the counter using this instruction, that is add a comma hash 99h, and you have to validate the BCD, that is you have to use decimal adjust after instruction to ensuring valid BCD representation. After this, you have to introduce a delay in order to slow down the counting process, and the loop continues, that is the process repeats in an infinite loop until it is stopped. The first step is initializing. So here these three steps are used for, that is instructions are used to initialize the program. First is the org directive, that is org 0000h. Here the program is set to start at this location. Then you have the next instruction as move a comma hash 99h. You have to load the accumulator with the number 99h. Next is move 30h comma a. So here the value is stored at RAM location 30h, which holds the current counter value. Okay. Then this is the main loop that is used for decrementing the counter. So here a subroutine is called, that is called delay subroutine. So delay subroutine is called, it initiates a delay to slow down the counting. After that you have add a comma hash 99h, that is add immediate value. It adds 99h to the accumulator to decrement. After that you have to use the decimal adjust after instruction that will adjust the accumulator for proper BCD representation. Then you have to move the content of the accumulator to 30h memory location, that is it will store the decremented BCD value in this memory location 30h. Then you have S jump, that is short jump up. It will jump to the label up and it repeats the counting process in an infinite loop. So this is how your down counter logic works. In the first iteration, in the accumulator, we have loaded the accumulator with 99h. Okay, that is add a comma 99h. Sorry, not this one. Here we have initialized the accumulator to 99h. So in the accumulator you have 99h. Then after this instruction, that is add a comma 99h, a value will be 132h, that is 99h plus 99h, it is 132h. Then you will use the decimal adjust after instruction. When you use DAA instruction, the value in the accumulator will be 98h. So initially it was 99 in the accumulator. After these two instructions, that is add a comma hash 99h and DAA, your value in the accumulator will be 98h. Similarly, in the second loop, now the value in the accumulator is 98h. So when you add 99 to this, you will get 131h. Then after decimal adjust after instruction, it will be 97. Okay, that is, it will be 97 in BCD. So it will be stored in the accumulator as, in the memory location as 97h. Similarly, it will continue up to 00h and it will restart once it reaches the 99h value. So this is the delay subroutine. Here you have to load R2 with 255, that is FFH. Then you have to load R3 with again 255. This is nothing but the initialization of the middle loop, and this was the initialization of the outer loop. Then you have load R4 with 255, that is initializing the inner loop. Once that is done, you have to decrement R4 here. DJNZ R4 comma up 1. This is the inner loop countdown. Then you have DJNZ R3 comma up 2. This is the middle loop countdown. It will decrement R3. And next you have DJNZ R2 comma up 3. That is, it is decrement R2. And this is nothing but the outer loop countdown. Okay. So here this decrement R4 comma up 1, it will decrement R4 and repeat until it is 0, and decrement this one DJNZ R3 comma up 2, it will decrement R3 and repeat until it is 0, and DJNZ R2 comma up 3, it will decrement R2 and it will repeat until it is a 0. So here this is a nested loop structure, and it is introduced to it is used to introduce a significant time delay, and this creates a long delay before returning. So once you are done with this, this will return to the main loop. This is the overall program. Okay. So what we are doing here, we are starting with org 0000h, then we are loading 99h in the accumulator, and that value it is loaded in the 30h memory location. Okay, that is moved in the 30h memory location. Then we will use the main loop that is used for decrementing the counter. Okay, here we will call a delay subroutine, okay, in order to create the delay, and then add a comma hash 99h. So here this will subtract 1 in the BCD form. Then you have the DA instruction, that is, it will adjust the accumulator to ensure proper BCD representation. Then you have to store the decremented value in the memory location, and the process will repeat in the infinite loop. This is the subroutine for the delay here, where we have called a like a call delay. We have called the delay subroutine here. And once the delay subroutine is executed, then it will return from the subroutine. Okay, then the program will end. Now we will see the execution of the program. I'll copy the program from here. Now go to the Keel software. Okay, maximize this. Go to project, new Mu Vision project. I will use the previously used project Alice and click on yes. Now search for 8089C51. Okay, here, and click on OK and click on no. Now go to the file, open new file, copy, type your program here. I'll copy the program here and save it. This is the BCD up counter. I'll name it as BCD up.asm. Okay. Oh, sorry, it is BCD down. Sorry, it is BCD down, not up. BCD down counter. So DW, I'll write it as DW.asm. Okay, now save it. Now go to the target, click on this plus symbol. You'll get source group 1. Right click on this and click on add existing files to group source group 1. Now search for your program, that is BCD DW, it is down counter. So add and close. Now check whether your program has been added in the source group 1 or no. So it is added here. Go to debug. Click on start or stop debug session. Sorry. you have to go to project, because we have not built the program yet. Okay, you have to go to project, you have to build the target, and you have to see whether you get any errors. Now you can go to debug session, start or stop debug session. Okay, now go to the memory and type I:30H, because we want to see the counter that is decrementing in 30H memory location. Now go to debug and run. Here you can see the value is being changing. Okay, it has started from 99 and it is decrementing. You can see here it is become 91, 90, 89, 88 and so on. Okay, and it will reach 0, 0. Then again it will restart from 99H, and you can stop this program at any time by going to debug and stop. Okay, this is the program for BCD down counter. Hope you have understood the program. Thank you. I will show you the execution once again here. So go to debug, start and stop debug session. Okay. Now you have to go to debug and run. So you can see here it has started from 99 and this value is decrementing. Here I'll show you how the value is decrementing. Here in the accumulator, first the value was 99. Okay, to this we are adding 99. Okay, now what is the answer? Answer is 198. So this 1 will be discarded and this 98 will be stored in the accumulator. Now the next value in the accumulator, it is 98. Okay, so 98, it is added again with 99. Now your answer is 97. That is 197. 1 will be discarded, it will be taken as a carry, and this 97 will be stored in the accumulator. So similarly, now the number is 97 in the accumulator. To this 99 is added and you get 196, and 1 is discarded whereas 96 is stored in the accumulator. So you can see here it is decrementing by 1. Okay, and here you can see the values are decrementing by 1. Now it is 76, 75, 74, 73 and so on. Okay, thank you.